Good morning everyone. I am Vandana, Assistant Professor in the Department of EIE, VNR VJIT. Today I am going to discuss about number-based conversions. The conversion of a number in base R is to decimal is done by expanding the number in a power series and adding all the terms. The conversion of a decimal integer into a number in base R is done by dividing the number and all successive quotients by R and accumulating the reminders. So this is how we will convert one number system into any number system into decimal system or from decimal to any other number systems. So let us see this in detail. As we know, there are four number systems which we will generally consider: decimal, binary, octal and hexadecimal number systems. So we will convert one number system into another number system. So here let us consider a decimal number system can be converted into the other three number systems. Likewise, a binary number system can be converted to other three number systems. So there will be a total of 12 conversions which can occur, that is from one number system to another system. In general, consider converting a decimal number first to all the other three number systems, that is a decimal to binary, octal and hexadecimal number system. So a decimal number can be converted to a binary number system by dividing the decimal number by 2. So let us consider a decimal number 41. So a base or radix is represented here, that is 10 for a decimal number. We want to convert it to a binary number. Binary means radix or base will be 2. So how we will convert a decimal number to binary number? What we will do is simply we will divide the number by 2 and accumulate the reminders. So 41 when divided by 2 will give 20 and the remainder will be 1. And 20 when divided by 2, the quotient is 10 and the remainder is 0. So 5 with a 0, 2 with a 1 and then 2, 1 and a 0. So we will do it until we will get a 0 here as a quotient. So here these are the reminders when we are dividing 41 with 2. So we will write all this from bottom to top. So whatever all the digits we are getting, 1, 0, 1, 0, 0, 1. So this is how we will convert a decimal number to binary number system. So we will divide the number with 2 and we will write down all the reminders and we will accumulate all the reminders from bottom to top. This is how we will convert a decimal to binary. So next let us consider a decimal number conversion to octal. Let us consider a decimal number 153 to the base 10. So convert it to an octal number. So how to convert a decimal number to octal number? Simply divide the decimal number by 8 and accumulate the reminders from top to 153 divided by 8, 173, 9 with a remainder 1 and 19 divided by 8. So we will get 2 with a remainder 3. We can stop here, or simply 8 with a 0, 2. So accumulate the reminders from bottom to top. So 153, a decimal number when converted to octal will be 231 to the base 8. So let us consider again a decimal number. Let us convert it to hexadecimal number system. As it is a hexadecimal number system, we have to divide it with 16. So 26814 to the base 10. We have to convert it to the base 16. So divide it with 16. So 16, 1, 6, then 7 and 5, and we will get the remainder which will be always less than 16. That so here you are getting it as 14. 14 means it will be our E. So write it as E, and then again divide it 1675 with 16, which is 104, and we will get the remainder as 11. 11 means it's B, and then 104 divided by 16 is 6 with a remainder 8. So we can stop here, or else simply 16, 0 and a 6 and accumulate the remainders from bottom to top, which is 6, 8, B, E. Right. So this is how we will convert an decimal number to hexadecimal number system. So any number, any decimal number can be converted to any radix r by dividing with that radix. Here, as the radix is 16 here, so as it is we want to convert to hexadecimal number system, we have divided with 16. Suppose here we have we want to convert it to octal number system, so we have divided with 8, and for the first one, as we want to convert it to binary, we have divided with 2. Right. Suppose if you want to convert it to some any radix r, which means that decimal number must be divided with r. So this is the generalized procedure of converting an decimal number to any base r. So likewise, let us consider converting any number system to decimal. So converting any number system to decimal. So again, let us start with a binary to decimal. So what we will do? For converting any number system to decimal, we will multiply it with the powers of r and then accumulate, and then we will add up all the terms. So let us consider a binary number 101001 to the base 2. Convert it to the decimal number. So here there is no radix point. So the first digit will be 0, 1, 2, 3, 4 and 5. So we will start up with adding all the terms in which there will be the quotient is 1, and we will omit the ones which are 0. Why? Because 0 into anything will be 0. So 1 into 2 power 5 plus 1 into 2 power 3 plus 1 into 2 power 0. So 32 plus 8 plus 1, which is nothing but our 41. I have taken the same binary number which we did for the first conversion of decimal to binary. So we have got back the result of 41, which is our decimal number. So next one, converting octal to decimal. So coming to octal to decimal, so let us take back the number 231 to the base 8. No octal point or no radix point here. So this is our 0, 1 and 2. So 2 into 8 square plus 3 into 8 power 1 plus 1 into 8 power 0. So 8 square 64. 2 into 64 plus 3 into 8, which is our 24 plus 1. So 128 plus 24 plus 1, which is our 153 to the base 10. Right. So this is how we will convert octal to decimal. So next, convert a hexadecimal number to decimal. So hexadecimal to decimal, we will multiply with powers of 16. So coming to the hexadecimal number, we have taken some 68B, or let us start with a simple number. 362 to the base 16, convert it to decimal. So 0, 1, 2, so which is our 3 into 16 square plus 6 into 16 power 1 plus 2 into 16 power 0. 3 into 16 square is 256 plus 16 into 6. 16 6 are 96 plus 2. So 256 into 3, 18, 16, 1, 7, 68 plus 96 plus 2, which will be, so 768 plus 96 plus 2, which is 866 to the base 10. So this is how we will convert an hexadecimal number to decimal number system. So we have converted from any base r to decimal by multiplying it with the powers of r. So we have converted binary to decimal, octal to decimal, and hexadecimal to decimal. So totally we have did 6 conversions. So let us concentrate on the remaining 6 conversions. So binary to octal and hexadecimal. So binary to octal and hexadecimal is very simple conversions. So let us consider a binary number 101011. So to the base 2. So here when we are converting a binary number to octal number, binary means 2 digits and octal means total 8 digits. When we represent a octal, that is 2 power 3. So 3 digits can be accumulated as an entity to be converted to octal. So 101. So 101 is our 5. And then 011 is our 3. So 101011 to be converted to octal is simply nothing but our 53 to the base 8. Right? So likewise, let this be the same. Take the same binary number and convert it to hexadecimal. When we are converting to hexadecimal, we have to group 4 numbers as an entity, as hexadecimal means 16, which is nothing but our 2 power 4. So 4 digits. So there are only 2. So we can insert 0 0 to the left. So 0 0 1 0, which is nothing but our 2. 1 0 1 1, 8 plus 2 10, 10 plus 1 11, 11 is nothing but our b. So 2b to the base 16. Right. So this is how we will convert a binary to octal and hexadecimal number systems. So next thing is conversion of octal to binary and hexadecimal. So coming to octal to binary, so 231 to the base 8, as it is a octal number, so simply write down for each digit, write down its equivalent 3-digit binary. So 2 means 0 1 0, 3 means 0 1 1, and 1 means 001. As it is a octal binary conversion, octal to binary conversion, for each digit use only 3-digit equivalent binary, right? So the same 231 to the base 8, if you want to convert it to hexadecimal, there won't be any direct conversion like this. But what we have to do is, it is very simple to convert octal to binary. So then go for grouping 4 numbers, because hexadecimal will be having grouping 4 digits. So 1001, which is our 9, and again 1001 is our 9. So 99 to the base 16, right? So octal to binary and octal to hexadecimal. And the next conversions are, so hexadecimal to binary octal. So coming to the hexadecimal, so let us consider some B9 6 to the base 16. So converting it to binary, so hexadecimal, when we want to convert it to binary, use 4-digit binary for each digit. So B is our 11, which is nothing but our 1 0 1 1, right? 9 will be our 1 0 0 1, 6 is 0 1 1 0. So this is our binary number, right? Next, converting hexadecimal to octal. So group 3 digits as an entity from this conversion of binary and then write down its equivalent octal number. So 0 1 1 0. So group 3 digits. Why only 3 digits? Because octal means 8, which is nothing but our 2 power 3, and hexadecimal means 16, which is nothing but our 2 power 4. So 101 is our 5, 110 is our 6, 0102, and 110 again our 6. So this is how we will convert a hexadecimal number to octal, and similarly hexadecimal to binary. So we have did all the 12 conversions. The first one is the decimal to binary, in which we have divided. So any decimal number to base r can be obtained by dividing the numbers and accumulating the reminders from bottom to top. So for the first 3 we have did it like this, and then next any r to decimal, that is we will multiply it with powers of r and we will add up all the values. So like the particular decimal number will be obtained. So total 6 conversions here, binary to octal and hexadecimal. How to do a binary to octal and hexadecimal? We will write down, or we will group 3 numbers as a digit, because octal means 8, which is nothing but our 3. So we have written its equivalent binary number. So, and coming to the hexadecimal, we have taken 4 numbers as an entity and we have written its equivalent hexadecimal number. So binary to octal and hexadecimal, and coming to octal to binary, we will write down for each digits, we will write down its equivalent 3-digit number, and same from octal to hexadecimal, as we have did the binary conversion, we will group those binary numbers as 4 numbers as an entity and we will write down its equivalent hexadecimal number, right? So this is how we will do octal to binary and hexadecimal. Likewise for hexadecimal to binary also the same thing. Hexadecimal, we will convert each digit to equivalent 4 bits and then we will group 3 numbers, because hexadecimal to octal will be grouping 3 numbers as an entity. So we have did total of 12 conversions. This is how we will convert one number system into another number system. It doesn't mean that there will be only 12 conversions. So here, as we have taken only 4 number systems which we will use in general in our real time systems or real time experiences. So what we did is simply we have taken the 4 number systems and we have converted one number system into another number systems. So this is about the number based conversions. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.